Right, students, welcome back to this video. So for this video, we'll be looking at the binomial theorem worksheet. Okay, so basically, what's going on is this. I will only go through question 3 and 5. Okay, because questions 1, 2, and 4 are relatively manageable and they are quite similar to what I'm going to go through. Okay, so for these two questions, I will simply just go through a sketch of their solution. So it serves as a hint for those of you who have some problems, right, attempting this, right? So before we start, let's recall two important formulas. The first formula is just the expansion formula for a plus b holding to the power of n. Okay, where n is a positive integer. So the first thing that you need to know is that when you expand this expression over here, you should get a to the power n plus n choose 1, a to the power n minus 1, b choose 1, right? Then you realize that the power for the first term decreases while the second term increases for each subsequent terms. Okay, so the last term would simply be n choose n, right? B to the power n. Okay, so that's the first formula. The second is your general term formula. Okay, tr plus 1, that will be equal to n choose r, a to the power of n minus r, b to the power of r. Okay, for this worksheet, you need to apply these two formulas, and let's see how we can do that. Okay, so let's just go to question 3. Where's question 3? Okay, so for this one, you see that the expansion of this expression over here to the power of 10. Okay, so what we want to do is to find, in terms of k, the term independent of x. Okay, so in this case, we realize that k is simply just some constants. Okay, so your variable is x. Okay, so how are we going to tackle this question? First of all, you need to know what does term independent of x means. Okay, you should know that this means x to the power of 0. So in short, this is your constant term. Okay, so applying the formula, let's first find the general term of this expression. So you should have 10 choose r, right? Because in this case, n is assumes the value of 10. Okay, the first term a, right, square root x over k square to the power of n minus r, so 10 minus r. Second term to the power of r. Okay, so you need to be able to write this down correctly. So you should be able to then get a 1 mark in your exam. So you need to write this thing, substitute, and apply the formula correctly. Okay, next, what do I do? Okay, so for me, whenever I see radicals, okay, I want to change them to their fractional powers. So in this case, this should be x power half, x power half. Okay, then all of the denominators I will bring up, okay, and join the numerator. Okay, so when you change, okay, you need to include a negative sign. So let's see how do we do that. The first step, okay, so we have x to the power half, right, k to the power of minus 2. Okay, then of course 10 to the power of minus the power of 10 minus r, right, and of course this would be k times of x to the power minus half, then of course the whole thing to the power of r. Okay, so next step, I'm going to simply apply this law of indices, right? A times b to the power n, right? You can split them into a power n times b power n. So I'm going to apply to these two terms over here. Okay, that I should get this very nice expression. Okay, so this would be simply x power half to the power of 10 minus r. So remember to put your brackets. So this would be k power minus 2, likewise holding to the power of 10 minus r, right? K to the power of r and x to the power of minus half holding to the power of r. Okay, so when you are at this step, you are halfway there. Now you need to apply this next indices formula. A to the power of m holding to the power of n is just basically the m times n, right? Okay, so the product of their these powers. Okay, so what are we going to do? I'm just going to apply this. You realize that you should get this expression over here, right? So for this term, you get half times 10 minus r. That's why you get 5 minus half r. Okay, so you do the same for the rest of the terms carefully. Right, next, identify the common terms. So you see that you have x, so same base. when you multiply them, you simply add their powers. So you should get x power 5 minus r. This is the brown term. And finally, the the terms with the k base, right? So you add their powers. So this is your k to the power of minus 20 plus 3r. Okay, so I just group all the constant terms together, right? So if I would like term independent of x, what I would do is I simply equate the power of the general term to be equals to 0. Okay, solving for r, straightforward, r equals to 5. Then I substitute back into the general term. Okay, so in short, you realize that the general term t, right, 5 plus 1, so t6, the sixth term, would then assume this constant value, which is also known as a term independent of x. So what you do is just simply substitute the r to be 5 for this expression over here, and you are done. Okay, right, let's look at question 5 now. So question 5 tells us that the first three terms in this expansion of in ascending orders of x4 of this term, right, where n is a positive integer, is this. So that means when I would expand this guy, okay, to get the first three terms, means that x to the power 0, x power 1, x to the power of 2, okay, I should get this p plus qx plus 2x squared exactly. Okay, then they just want us to find the values of n, p, and q. So how do we do that? Simple. The first thing you do is, okay, to be able to express this guy, 1 minus x over 2 to the power n, okay, you need to expand this. So you use your formula. What do you get? You should get, right, first term to the power n plus n choose 1, right, 1 to the power n minus 1 minus x over 2 to the power of n, to the power 1. Okay, then you realize that every time you expand, the first term power drops by 1 and the second term power increases by 1. Okay, but you realize that the first term is always base 1, so 1 to the power anything is 1, so we can just ignore. Okay, so we just focus on the second term. Okay, so the second term would just be n choose 2, right, minus x over 2 squared, right, plus dot dot dot. Okay, because I don't care really the subsequent terms, because I would just simply want until x squared term. The constant multiplied by this x squared term would give me the x squared term. Okay, so next we have to just simply do our remove method, right? Okay, let me just tidy this up first. Okay, 1 power n is 1, n choose 1 is n, if you recall, n times this guy over here, this would simply be minus nx over 2, right? And if you recall, n choose 2 is n multiplied by n minus 1 over 2, right? Factorial. Okay, so in this case 2 factorial is 2, so this is just n times n minus 1 over 2 minus x over 2 squared plus dot dot dot. Okay, so up to this step you should be okay, right? You want the first three terms, so you just like to expand it until you get x squared, the constant x and x squared. So let's look at the constant term first. If you multiply in these three terms, you should get, okay, what you want. Next, for 3x, if you multiply by 1, you get the x term. You multiply by the second x term, you get x squared term. So you stop there. You don't multiply again, okay, because otherwise you'll get an x cubed term. Okay, so what you do finally is simply just to tidy up. Okay, expand. I leave you to do that. So you should get a constant plus some x term plus some x squared terms. Okay, and this is equivalent to p plus qx plus 2x squared. Okay, so this is what the question has given to you. So clearly we see that now the constant term, right, would assume the value of p, right? The coefficient of x would assume the value of q, and of course lastly the coefficient of x squared assumes the value of 2. Okay, so you would write comparing coefficient Okay, so P would be what, then of course Q would be what, so on and so forth. Okay, and of course your N would be some terms which you would need to find out on your own. Okay, so I'll leave you here to try the rest of the simplification and the rest of the questions. So let us know if you have any questions. Okay, this is the end of the video.